All right, so I just want to make this kind of short and sweet, and just, to my knowledge, no one has actually created any video reviews yet of the Ultra motherboard from ASRock yet. It just came out in December, so I think I'm one of the first people to actually have a working server build using this motherboard from ASRock Rack. The reason why it's really cool is because it's using a high core count ARM processor instead of the usual Intel or x86 AMD, high core count, relatively high core count, but super expensive processors from Intel and AMD. But you can have like much more energy efficient high core count ARM in your very own home server now. Oracle Cloud has had this for a while. They've had ARM Ampere Altra CPUs that you can use even for free. But I'm trying to decloud myself and remove my dependency on these big tech companies. So I'm trying to move everything to Homelab / home server setups. So, I have a bit of a setup here with it, a NAS, a UPS, custom router using OPN Sense, and another Proxmox node. So the final piece here is just some suitable source of compute power to act as a home server that is also power efficient and can, allow me to virtualize many virtual servers at the same time. So this is basically it. It's a Proxmox workhorse that's going to be mounting the 5 hard drive, 40 plus terabyte NAS storage over CIFS or NFS. I haven't decided which one yet, which is a separate TrueNAS box fit for purpose. It's only doing the serving. It's not doing any computing. It's just doing the storage server piece. And then this guy here has two 10 gigabit NICs on here, and my switch that I have, it's a no-name. It has these two 10 gigabit four 10 gigabit SFP plus ports. So I'm gonna use both of those in tandem here, for maybe LLAG multi-interface to connect this server to the rest of the network, and to be able to just talk to my NAS and mount its storage as a networking device for the storage uses of the server. Now, cobbling this together as a build was actually pretty difficult. I did have to do some trial and error with ordering and wasting money on parts because there's just simply no guidance yet. This is just very early board. It's the first, I would say, mini ITX, or as they call it, deep ITX. It's slightly larger than the normal ITX form factor from ASRock. It has a single CPU socket as opposed to a multi CPU or dual CPU socket, which is the one I saw from Gigabyte, which wasn't going to work because I'm hoping for something short depth, like 15 to 17 inches tops, that'll fit into my server cabinet. So then I landed on this, Rosewill case 2U. It does have some extra drive cages, but I did have to remove them because this ITX form factor is called Deep ITX. It is about an inch or two deeper than the normal size mini ITX. So even though this does support mini ITX boards with drive cages, and actually, come to think of it, these drive cages might actually be slightly elevated such that it wouldn't be a short circuit. I just wasn't going to take any chances. I'm not using this server, if you will, for storage. That's the job of my NAS, so I just removed the drive cages. Most notably, I did leave this one in because there is a 5.25 inch drive bay at the front of the case. That one there is, if you, the actual front panel here is connected physically to this cage. So if I take it out, there's going to be a hole in the front of the server case. But that's just unused space anyway, so who cares? It does make my cables a bit less managed than they normally are, but I wouldn't say cable management was ever my strong suit, so to speak, let's talk about part selection. So obviously you need the ASRock board, the Ampere Altra board that they sell. You know, I will say there's two comments about this. The first one is there's a bundle and a non-bundle. I was a bit overly thrifty and decided to get the non-bundle because there was an eBay seller selling these CPUs for less than the actual bundle amount. So I tried to save some money, but ultimately did not prevail because the bundle has a 2U heatsink included that I cannot find for sale absolutely anywhere else. I do have this 1U heatsink that I found from Supermicro. You know, it is passively cooled. It does get pretty hot to the touch, which is a bit disconcerting, but I've had it running all weekend, and I've even monitored the temperatures during heavy loads with, you know, artificial benchmarking suites like Hynix, and it's fine. The temperature just stays in, you know, I would say the highest it's ever gone is 70 Celsius. Now, granted, I don't have the top case panel attached when I was doing these tests, but what I did do was I replaced these stock fans here. These aren't the stock, these are Noctua's. What are these? These are the 80 millimeter Redux fans. 1800 RPM, I believe, is the number here. What I want is just high CFM fans. You know, instead of these are sort of lousy ones that they're quiet, but they just don't push enough air for something that is only going to be passively cooled, right? Now, another drawback to this 1U Supermicro cooler, which I was very fortunate to find because these coolers are rare, they're scarce, is that this thing actually covers up 2, or, you know, I would say 2 plus a half on each side, so 4. 3. Actually, it makes 4 unusable total DRAM slots. Now that's a bit of a pain. See, it just ever so slightly covers the DRAM. Now that segues into my next point. You know, I've been someone who's only ever built desktops before for the last decade, and I didn't realize that desktops use a different kind of memory than servers, even if it's non-ECC. Server memory is UDIMM, or I'm sorry, it's RDIMM. Desktop memory is UDIMM. And if you mix and match the two with this particular board, it's not going to boot. And there's no memory QVL list, and it's just very vaguely mentioned that you need to use RDIMM memory. So what you're looking for is anything that is server grade or RDIMM, or registered is the operative word if you see the word registered. Actually finding this DDR4 3200 registered RDIMM was a bit tricky, but I found some from Kingston on Newegg, which I can drop a link. You know, there's assembled in Taiwan. It's, you know, actually SK Hynix memory chips, so it's, you know, it's tied. It's SK Hynix. It's tied to Korea. It's using Korean chips. The way I found out about this memory is that, you know, there were some nearest neighbors from Kingston that were listed as supported on the QVL from Gigabyte. A Gigabyte board, the dual CPU motherboard for Ampere Altra, probably the only other motherboard that I can find that does Ampere Altra. That one had a populated QVL. The ASRock one did not. And so I assumed that, you know, anything from the Gigabyte board's QVL will probably work fine with the ASRock board's QVL. Or, I'm sorry, it's just, you know. And unfortunately, they didn't have the exact letters, like the model numbers. This one here was not in the list of supported memory for even the Gigabyte. But because it was registered memory, and DDR4 in the same speed, same clock rate, I thought, okay, it's going to work. And sure enough, it did work. That segues into my next point. Troubleshooting this is an absolute nightmare. This board it doesn't have post codes. I even attached the little speaker here, you know, this guy. It's a piezoelectric speaker that you can just plug into the header on the board. That does not chirp or beep at all if there's a problem when you're booting. If you're missing memory, if there's no CPU, and I've tried all these things. If you're missing a power connector, there are no post codes. It is really hard to debug this. In fact, they even have this, let me see what it's called here. I believe it's called OpenBMC. It's IPMI interface. That thing is also next to useless. OpenBMC, yes, that's what it's called. And the reason why is because everything shows up as healthy all the time. If there's no memory, all the memory slots show up as healthy. If it's incorrect memory, like it's UDIMM desktop memory, all the memory slots show up as healthy. Very tricky to troubleshoot. CPU is always healthy too, green checkbox, even when the CPU is not plugged in. That makes it extremely difficult to troubleshoot. But, and then, you know, just to add another wrinkle of depth to the fun, this particular board actually takes a good amount of 30 to 60 seconds before the board actually powers on. Like you press this, you know, front panel power connector, which I've also just tried shorting myself with a screwdriver since it's just, you know, a pin with voltage going to, you know, or I'm sorry, it's not a pin with voltage. You're just pulling a line low to the ground. It's a digital I/O pin. You're pulling it too low to the ground. It's a power pin on the panel connector. And that is enough to tell the board to kick on and power on, right? But it doesn't, you know, it's a couple more green lights show up on the board. In fact, let me just demonstrate this. I'm gonna turn it off. You know, nothing's really that important on this thing. Okay, it's off, right? I just killed the power. So I'm gonna turn it back on, okay? Now, you'll notice a couple things. There's this heart beating LED here. It's gonna blink. The lane lights are gonna come on. There's an LED here, but I don't know what it's for. It's just a button with an LED attached to it, and it's going to be off. You can press the button to toggle it, but the button doesn't have any real functionality. And then there's some LEDs here for diagnostics, and this one basically just says, okay, there's power going through it, but it's not doing anything else. There's a manual that explains what these are, and this one is for diagnostics. The second one, the one, you know, towards the bottom of the camera, away from the chip with the label on it and the screw. This one here, to be clear, is, you know, it's indicating whether there's a fault or anything like that, and it's always going to be green no matter what, even if there's no memory in there, the wrong memory or the wrong CPU. So these LEDs are just next to useless. Now I press the power button, right? Okay, there's some more LEDs that light up here. This guy is eventually going to start heart beating, but nothing's going on, right? The power fans are not spinning right now, right? They are stationary. Yeah, there we go. It is not on. In fact, if I go into my router, there will, you know, and I'm using the IPMI interface, the IPMI DHCP4 leads will be shown as disconnected. The network connection to the BMC itself will not show up. Okay, it has clicked on. There was a relay that clicked, okay? All right, so now we're starting to see some signs of life. The network port is blinking. The blue LED on the back, which is not really useful, just turned on. And this thing here is blinking because it is a BMC heartbeat. Now, if I were to go and ping the network interface for the IPMI, I will start seeing some responses, but the board itself is still off, okay? Okay, actually, no, I take that back. It has finally kicked on. And the reason why I know that is because the fan's powered on. The fans power on when the board is on and the CPU is on. Now, that's not enough for this thing to actually show anything for the booting yet, okay? So, if you have this VGA cable plugged in here for the video output, which, you know, that's another point of contention here, you do not need a video card. It is built in. I just want to be extra clear about that because it's not very clear looking in the documentation whether you actually need a GPU. or not, okay? So I plugged in the VGA into a monitor, and I'm not gonna see anything from this VGA until another minute or so, even though the fans are spinning. And the blue light that I don't know what it's for is blinking, the heartbeat's heartbeating, and you notice that there are now 2 LEDs here powered on, the third LED over here, and then this one has an additional LED as well. So how do I know this is working, right? You don't. You just have to keep waiting. And for the longest time, I thought that even though I had switched to the server memory, you know, that this board was dead. I thought the board was dead or the CPU was dead. And I was pulling my hair out. I tried a different power supply. I tried 2 different types of memory. I also wasn't sure about these extra CPU headers that they have, or sorry, these 12-volt CPU power connector headers that they have. So conveniently, this Corsair power supply actually comes with 2 CPU power connector cables, almost as if they want to actually support having 2 CPU socket motherboards, right? So I was able to plug in one of those and then the main one here, and then there's another one that I had to get an adapter for from Amazon that converts a PCI Express connector to a, let's see here, this is not the adapter, this is the original power. Let me see if I can find that guy. Okay, here it is, look. There's a PCI connector here that you can, it's a female PCIe connector, okay? 8-pin, because I want to use all the pins that I have. And then there's a male connector that is a 12-volt ATX EPS CPU power connector, right? So I have that. And then I was going into the third one here, right? And so actually, you know, technically I don't need an adapter because look, this guy is a modular Corsair power supply with Type 5 connectors. So if I can find a Type 5 connector that is directly another spare CPU power connector, because look, they're all the same, you know, 8-pin, I believe that's 8-pin Type 5 connectors, then I could just plug another one in directly. So guess what? I look everywhere. Corsair does not sell individual ones. They only sell the bundles. But there is a modder site called MODDIY that does sell the cable. So I actually ordered the cable, and I'm going to just swap it out from the adapter. They are making that cable custom for me. They do make Type 5 cables. Type 5 cables are rare. I can't find them anywhere else, and Corsair does not sell them individually. So at the end of the day, I'll have 3 12-volt EPS ATX CPU power connectors going into the motherboard. And then the last point here to make on the power side is that this, you know, ATX 24-pin connector actually goes into an adapter, which then goes into, I believe it's an 8-pin connector here. Sorry, I think it's a 4-pin, not an 8-pin connector there. And that is your main power, right? Now, the manual doesn't say whether these are optional or not, but from talking to others, and just in general, like if there are power connectors on the board, I'm gonna wanna populate them. Now, there's one last caveat about these power cables, right? Using an adapter to go from PCIe to ATX means you lose one 12-volt pin. Now, depending on the architecture of the power supply circuitry itself, that may or may not be a problem. If it's already shorted, then it's fine. If it's on separate rails, then you're going to be, you know, potentially underutilizing or overutilizing certain power rails by drawing more current than they're designed for. That should hopefully be a moot point. I will say that this adapter that goes from PCIe to ATX is losing a pin in the process, but if I use a replacement cable, I will have each 12-volt pin will be its own connection directly to the power supply itself rather than shorting. So it's actually slightly preferable to use the cable itself rather than an adapter from PCIe, because you do lose that pin that's sending 12 volts from the power supply directly to it. Now back to the cooling side, right? One thing to mention here is with this particular Rosewill case, there is no clearance on the top or the bottom if you're using a full-size ATX power supply. So you need one with front-to-back cooling. Naturally, if I look on the interwebs, right, there's no power supplies that are very recently made with front-to-back cooling. Oh, that's annoying, right? Power supplies from 2006 and earlier, plenty of them have it. Like there's a Seasonic 600 watt power supply that has it, but none of them are modular and none of them have like all the modern connectors like PCIe and SATA that you would expect from a power supply. So the next best thing is there's this SFX form factor that's actually smaller than ATX, and it comes with a mounting bracket for ATX, and that gives us about, let's just say, a ½ inch to an inch of clearance underneath this guy, and then there's a fan at the bottom, and then that, if I, trying to feel it with my fingers to see how hot it is, it's perfectly fine. So that fan has enough clearance to actually keep the power supply cool enough during use. So that's how I worked around that. It would be nice if I could just use like a 1U or a 2U power supply, but this case was really designed for ATX only. So, I wasn't gonna just like delve into modding this. Speaking of modding, there's actually, an alternative way to cool this. There's 3 ways to cool this thing. Number 1, you buy the bundle and you get a 2U passive cooling heatsink. I cannot find that thing anywhere else. I even emailed ASRock asking about it. That is the only way you can get this 2U cooler, which ideally you want to have this thing because there's more surface area to the fins on the heatsink. So your ability to dissipate heat will be greater. But there's also the 1U heatsink from Supermicro that I could only find on one e-commerce site that I never heard of before, and the listing didn't have a photo, but it had the exact name and model number, so I just rolled the dice, and guess what? It was what it advertised. It is a 1U passive cooler that's compatible with this particular socket, which is a unique one, okay? It's the Ampere Altra CPU socket is not used by any other CPUs from Intel or AMD. So almost all of the pre-existing cooling solutions on the market are not going to be compatible with this, okay? That is option number 2, the 1U one that's sold separately that, I suspect after, about 10 more orders, it's going to be completely out of stock. Okay. And then your third and last option is water cooling. There's a special mounting bracket here from, what's this company called? I think it's Alphacool, yes, it's a German company. They make this all-in-one Aurora Pro 240 Eisbaer. Pardon my mispronunciation as a German American. This guy here actually has a bracket with the right spacing between the holes. And now here's the thing. This is not a heatsink, this is not a, thermal grease application. This is a cooling pad. And why do I need a cooling pad? It's because even with this special mounting bracket, this particular cooler does not fit. There is some depth to the CPU socket, even with the CPU installed. And so this is not going to make physical contact with the CPU itself unless you have this pad. This is a 3mm one. I believe it was 100 by 100 millimeters, but the actual amount that I needed was much smaller, so I had to cut it with scissors. Obviously, I'm not using this now for a variety of reasons, but it is a water cooling setup that works. And it comes with these, I believe these are 120 millimeter fans, but and of course, this is a 2U case, so it's only 80 millimeters high. So these 120 millimeter radiator plus fans combo is not going to work. Now, some people actually, divert this out through here, there's a dry bay. You can remove this, you can route this out through the dry bay and have the radiator sitting outside the server case. But, that's not very elegant, right? And how am I going to fit that in my rack? And where am I going to put this thing? And it's just, a lot of headaches. Another possibility is just to actually get a 2U radiator and, drill holes into the case and mod the case to have a 2U radiator in your loop. And I believe that should be possible. Like, you can just detach these and reattach them to a 2U radiator and have a custom water cooling setup there. Now, I will caution that, there's a limited amount of clearance here between the board and the fans already. So you're going to be pushing it if you try to do that. Last thing you want is your metal water cooler radiator fins shorting your motherboard, right? And this is not a cheap motherboard. It is $800. So it's a bit of an expensive endeavor. And that brings my next point is the price of this whole setup. It's a boutique niche setup, right? So the CPU is going to be anywhere from $300 to $500, depending on how lucky you are on eBay. The board itself is $800, $850, just the board. And that's not with the cooler included. You can buy a bundle with the CPU, the motherboard, and the cooler all together, and that'll be about $1,500. And that actually sounds like the best option at this point, because the cooler, if you're building a 2U server, you want a 2U cooler. If you're building a 1U server, which should be possible, but I don't know, I just like the idea of having a 2U server. This is easier to work with and it's easier to cool. So you could actually build a 1U server with this thing, with the 1U cooler from Supermicro. But for short depth, I would argue that having the extra clearance, 40 millimeters of clearance, so to speak, will be more useful for cooling this thing and making it easier to work with. But if you're, you have the rack space for a 24-inch plus depth server case, server chassis, then, maybe you could look at a 1U solution. But anyhow, I digress. Power supply, 100 watts is overkill. I'm measuring 200 watts to 500 watts, just, eyeballing my UPS, which has a wattage readout when it's plugged in. Let's see here. Let's just see what it's like now. Okay, that's just the voltage, load, 21%. Okay, so that, 198 watts. That's with some other stuff in there already using about 30 watts. So this thing doesn't really draw too much power, even with like 100% load on all 64 cores. So, you don't need this 1,000 watt modular power supply. That's a bit overkill. I would say 500 watts should be more than enough. And then, I just want to talk about like the features of this board. It has these two MU slots here, which is awesome. I have a 1 terabyte WD NVMe SSD in there right now. And I'm thinking about actually having a TPU in the second slot for doing some hardware accelerated AI computations. There's also these PCIe slots. So you can have a half height or even full height, chassis permitting GPU in here. And guess what? NVIDIA definitely has drivers for ARM for this. I don't know about AMD, but I would be shocked if they didn't, given that NVIDIA does, and they're, mostly in lockstep with what NVIDIA does. So you can just put a normal GPU in here. That is freaking awesome, actually. And, the reason why is because that makes us like a de facto competitor to x86 for even desktop workloads. Like you can totally game on this thing if you want. It's not just for servers, but the appeal of this is just for purely for virtualization and server applications. Having this low power, high core count CPU is just freaking awesome, and it's very reasonably priced. It's definitely on the expensive side in terms of server parts, but in terms of like actually having 64, cores in a single server, you're looking at like Epic or Threadripper and spending like at least $3,000 on the whole thing. And this thing here, I would estimate everything included was under $2,000, which is freaking awesome. Now, don't knock ARM either, because the ARM architecture, it's not an exotic CPU architecture. It's very well supported. Every household name major Linux distribution has an ARM distribution. Somebody even forked and customized or cross-compiled Proxmox to run on ARM. So like this thing is actually pretty incredible. And I was running through some benchmarks with this, just doing some things like, calculate pi or decompress some zip files, or, there's this Phoronix suite they can run. This just runs like a host of benchmarks, anywhere from artificial workloads to actual real world mocked workloads, like decoding video, for example, or doing some matrix math. And man, just seeing 64 cores, not 64 threads, 64 cores parallelizing these workloads is just incredible. And, I will actually just segue this video or do a part 2 to talk about these benchmarks. I think that as much as you can call this thing a niche, which it very much is, it does fill a void in the market, in the sense that, in terms of cost to power ratio, it's along the Pareto front of, things that make sense in terms of bang to buck, right? So, I just can't stop gushing over how awesome this thing is. Let me just anecdotally, I can still touch this. I'm not burning my hands. That's how cool it is. And it stays that cool even under workloads. 64 freaking cores. You could run so many VMs of this thing. I mean, there's people that run Proxmox with only 4 cores and 8 threads, and they're doing just fine. This thing has 64 bona fide cores. Now, there's 8 slots here. This is a single 64 RAM stick, but you can just easily put another one here. And then you can, I'm gonna actually do that. It's $135, which is a bit expensive for RAM, but it's registered error correcting RAM, server grade memory, and I'll have 128 gigabytes of RAM that can be used for across multiple VMs or containers. So that's just freaking awesome. It's like a de facto replacement for $100, $200 per month in cloud computing costs at home. Now, whether that actually makes sense or not is, it's still like relatively, you're still paying the upfront cost of, say, $2,000 for the hardware. Let's just amortize that over, let's just say, 5 years, right? And then, you do the math, and depending on what kind of, depending on how expensive electricity is in your area, and, as there's a huge variability based on, where you are in the US, how much the electricity is going to cost. I would say that this does break even in terms of costs. And the reason why I like this more is because I actually own the hardware, and not only that, I own the data. I'm not subject to the whims of a giant, $1 trillion company that, outsources their servers in the form of cloud computing. I'm not at their whim to, whether they, decide to, let's just say, change their terms of services, retroactively, or, downgrade, or, place, new surprise restrictions, or change their billing and increase their prices, or any of the many myriad ways a $1 trillion company that doesn't have your true interest in mind can screw you over. I am in some sense liberated from that by having my own home setup in a part of the US that has very, inexpensive and let's just say, ecologically friendly power. And it's freaking awesome. Just in terms of where I'd rather spend my money, I'd rather have a tangible asset and pay for the electricity than pay the same amount for a subscription, if you will, to Oracle or any other company that does this. So note that I'm tacitly ignoring the fact that this was originally a free offering on Oracle, but I digress. Anyhow, last but not least, here's the box. They give you very limited things inside. They give you the board, some screws, some adapters that I didn't end up using, and that's about it. And then, you're on your own here. CPU I got on eBay. It was literally just the CPU itself, no core. And then, toss in the NVMe SSD, which was a bargain basement price. I think it was like $30 for 1 terabyte. That's freaking awesome. And then the memory here, which was server grade Kingston memory from SK Hynix. And then, modular power supply. And then last but not least, these 2 Noctua fans. And that was the build, and it is working fantastic. And it literally runs everything I need it to. Great. And at a much better cost than anything from AMD and Intel. So yeah, this is definitely one of the most promising home server, home lab, Proxmox type hardware solutions of 2024. And despite all the hiccups I had with the memory and getting the thing to power on and work properly, that this thing is amazing. And I'm willing to set aside all these early adopter shortcomings, frustrations, and I'm hoping that this YouTube video actually helps prevent others from making the same mistakes I did, which there were lots of mistakes and lots of frustration and lots of pulled hair, but luckily, just by publishing a list of parts that's working, I believe that this will help a lot of people that are looking into building similar things. And so, yeah, thanks for listening in and, putting up with my, unabated ramblings about this system build. And I hope that, you are similarly inspired to potentially look into building your own, because again, 64 cores, $2,000 in parts total, freaking awesome. You can probably get it down to $1,500 in parts if you already have the stuff laying around at home, and electricity costs are like zilch. It is. ARM as an architecture is super power efficient compared to Intel and AMD. So yeah, this is definitely the underdog, here, the dark horse in the race of server, home grade, home lab servers. And let me know how you think about it, and if you decide to build something on your own, and how it goes. Thank you so much. Bye.